So I just thought in case we run out of time during our session, then maybe I should just like solve some of these problems so that you're able to go back and see how we work through them. So for a function like y equals 3x squared plus 5x plus 8, to find the derivative or y prime, we just take the derivative of each of these individual terms. And so the derivative of 3x squared, we'll just write the 3 here. And the derivative of 3x squared, so bring down this 2 here. So it's 2 times x, and then we subtract a 1 from this 2 here. So it's going to be 1 minus, we do the 5 here. And so if you think of it as being a 1 up there, you do times 1 times x to the power 0. And the derivative of a constant is 0. So it's just going to be 0. So in the end, we have that this derivative is 3 times 2, that's going to be 6x minus 5. And to find the derivative of 4x cubed minus the cube root of x, well, if we write this as 4x cubed minus, well, the cube root can be written as 1 over 3, so it's 1 over 3. And so the derivative, which we will call f prime of x, is going to be, so we multiply by 3. So we do 4 times 3. So we write the x, and then we subtract a 1 from the 3. So it's going to be a 2 up here. Minus the derivative of this guy. Well, we bring down the 1/3. It's going to be 1 over 3 times x. And then we have to do 1/3 minus 1, which is negative 2/3. So this is negative 1 over 3 raised to the power negative 2/3. And then to find the derivative, so to find the derivative of this function here, you pretty, wait, hold on. How do we do this now? So to find the derivative of g of x equals 8x minus 4 over x squared, you have to recall that what the quotient rule is. So the derivative of f over g, so you put g squared at the bottom, and then you do g times the derivative of f minus f times the derivative of g. So in this case, our g is x squared, and our f is equal to, well, our f is 8x minus 4. So the derivative of g is equal to 2x, and the derivative of f, so f prime, is equal to just 8. So what we do here is we have, so we'll just have the derivative of g of x. We come up down here and put x squared raised to the power 2, and then we bring up x squared here, and then we multiply this by the derivative of f, which is 8, and then we'll subtract f. So f is 8x minus 4, and then we just multiply that term by the derivative of g. So this is 2x. So this then just becomes, so it's 8x squared minus, well, if we multiply 2x into this, it's going to be minus 16x squared. And if we multiply 2x into this, that's going to be plus 8x. And then we do all of this all divided by, well, x squared raised to the power 2. You just multiply these exponents here. So this is x to the power 4. Okay, perfect. Well, if we try to find the derivative of h, so h of x is equal to x squared into x minus 3. And the easiest way to do this is just to say, well, I'll just multiply the x squared in here. So x squared times x, which is just x to the power 1, minus x squared times, well, plus x squared times negative 3. Well, this is x cubed minus 3x squared. Well, then to find the derivative, which we call h prime of x, well, to find this derivative, we'll just we'll do the derivative of each of these terms. So the derivative of x cubed, well, you bring down an x here, and then you bring down the 3 exponents. So it's 3 times x, and then you subtract a 2 from the exponent. You subtract a 1 from the exponent, so you get a 2. Minus 3 times, you bring down the 2, so it's 2 times. You have an x here, and then you subtract a 1 from 2, you get a 1. So the derivative of this guy is equal to 3x squared minus 6x. The other way that you could have done this is something called the product rule. The product rule. And basically the product rule says if you want to find the derivative of a product of two functions f times g, well, you'll just you'll take the derivative of g of f, multiply that by g, and then add the derivative of g, multiply that by f. Okay, and so let's do that here. So in this case, our f, so f is equal to x squared, and the derivative of f is equal to 2x. And then our g is equal to x minus 3, and the derivative of g is equal to just 1. Okay, so then if we do the derivative of x squared into x minus 3, well, this is just the derivative of f, which is 2x into g, and g is what? X minus 3, plus the derivative of g, which is 1 times f, and f is x squared. So this is just, well, this is 2x into x. That's going to be 2x squared. And then 2x into negative 3 is going to be negative 6x plus x. And so this just becomes 3x squared, oh, sorry, this is x squared, minus 6x. So both answers will get you to the same position, but I, for one, prefer, if you can get away with doing this, this is a much more easier task to deal with. Okay, so we move on to number 5. Y equals cos of x minus e of x plus secant of x. Well, the derivative of this function is going to be the derivative of each of these individual terms. Well, the derivative of cos of x is equal to negative sine of x. The derivative of e to the x is just e to the x. and the derivative of secant of x is negative secant of x times tan of x. So like this is not about technique as much as just like remembering what the derivative of cos of x is, and it's that. The derivative of this is it's that. The derivative of this is that. Okay. And then we go on to number 6. So number 6 is f of x equals tan x minus cotangent of x. Well, if you're trying to find the derivative of f of x, which we write as f prime of x, well, again, we have to take the derivative of each of these terms. The derivative of tan of x is equal to secant squared of x minus the derivative of cotangent of x. Well, that's going to be negative cosecant squared of x, which is equal to secant squared of x plus cosecant squared of x. And this is a correct answer. But if you remember some more trigonometry from last year or whenever you did trig, you can simplify this and show that it's equal to 4 times the cosecant squared of 2x. Sorry, I'm actually not sure about this, so and I don't want to do the work that I have to do to verify, so maybe if we just leave this out, okay? If we just leave this out, we'll be fine. So just scratch this and leave it out. So forget about this. Forget I said this. I don't want to do the work required to verify this. So g of x equals 5 over x squared. Again, there's 2 ways that you could do this. And the easiest one, in my opinion, is just noting that you could write 5 over square root of x as 5 times x to the power negative half. And so like the square root, so the square root of x is equal to x to the power half. But because it's right here at the bottom, if you take it to be in the same level as the 5, you just add a negative sign to it. Okay. So once you have things written in this way, you could just easily take the derivative by saying g prime of x is equal to, you have this 5 here, and then you bring down this -2, so it's negative half, my bad. And then you have an x, and then you have to do negative half minus 1, which is, if you do this calculation, this is going to be -3 over 2. So this is x to the power -3 over 2. So, and this is just equal to -5 over 2 x to the -3 over 2. Okay, so this is one correct answer. And the other way that you could do this is to use the quotient rule. Okay, and we did the quotient rule before. So you just take whatever is in the bottom, so the square root of x, and you square it, and then you put square root of x here, and you multiply it by the derivative of 5. Derivative of 5 is 0. And then from that you subtract, well, square root of x is equal to x to the power half. You subtract 5 times the derivative of this guy, and the derivative of so yeah, times 5 minus the derivative of square root of x. Derivative of square root of x is 1 over 2, and then x to the, so you want to do 1/2 minus 1 is just negative half. So this then just becomes, so this is 0, it goes away. So you have negative 5 over 2x to the power negative half, okay, divided by x. Cool. So since you're dividing x, sorry, I'm moving around. So x to the power negative half divided by x to the power 1. We'll just subtract the indices. So this is x to the power negative half minus 1, which is x to the power negative 3 over 2. So this then just becomes negative 5 over 2 x to the power negative 3 over 2, which we had gotten here. So either method is correct. I personally feel like this first method is easier, but that's going to be up to you which way you go. Okay, so if we move on to number 8, h of x is equal to 8 plus 3 over x squared plus the cosecant of x. And if you want to find the derivative of h of x, which is h prime of x, we just take the derivative of this individual terms, okay? Derivative of 8 is 0. You could write 3 over x squared by saying, if I want to bring x to the same level as 3, this is just going to be 3x to the power negative 2, okay? And to find the derivative of x to the power negative 2, so we'll just, here, we bring down 3, and then we multiply by negative 2, and we have an x. So the exponent will be negative 2 minus 1, negative 2 minus 1 is equal to negative 3. So the correct answer is going to be negative 3 plus the derivative of cosecant of x is equal to cotangent of x times the cosecant of x. And if you just write this down in a more compact way, you have negative 6x to the power negative 3 plus, well, sorry, this is going to be, yeah, the derivative of cosecant of x is negative cotangent of x times cosecant of x. So this is going to be minus cotangent of x times cosecant of x, okay? So solve the following word problems. A ball is dropped from a height of 320 feet. Find the velocity of the ball when it hits the ground. Well, to solve questions like this, you have to know this equation. S is equal to ut plus 1 over 2 gt squared. And u is just like the initial speed, or how fast the thing is moving in the beginning. So since the ball here is being dropped, this u is going to be 0. And g, well, g is the acceleration due to gravity. And especially in our case, since we're in feet, the value of g is equal to feet, it is 32.174 feet per second squared. Okay, cool. So since we have this, we can find the time it takes for this whole thing to happen. So if we just write s is equal to 0, because the initial speed is 0 times t, plus 1 over 2 times g is 32.174 times t squared. And so we do know what s is. It's the distance that the ball will be dropped. So we'll have 320 is equal to 1 over 2 times 32.174 times t squared. And then we could just multiply by 2 on both sides and then divide by this and then take the square root to get the t is going to be equal to 4.46 seconds. Okay. So now that we have the time, which is how long this whole thing goes from like dropping the ball from 350 feet to the ball hitting the ground, we just need a formula for the speed so we can substitute, or for the velocity, so we can substitute in this value for t and get the velocity. So since we have that as the distance, ew, ew. So we have that ut plus 1 over 2 gt squared. So this is the formula for the displacement, or it just describes how our rock moves or our ball moves. So we just, if we take the derivative of this, we get the velocity. So v is equal to s prime, which is equal to u, since the derivative, we're differentiating with respect to t. So differentiating with respect to t. So if we differentiate this with respect to t, we just get a u, plus if we differentiate this with respect to t, well, we bring this 2 down here. So we have 2 over 2 gt, okay? So our formula for velocity is v is equal to u plus gt, okay? So since we know that u is 0, because this object starts at 0, we just have that v is going to be g times t, okay? And then if we bring this up here, so we have v is equal to, this is our value for g. G is 32.174. And then we just multiply that by t, the amount of time it takes for that ball to drop to hit the ground, which is 4.46 seconds. So if we just multiply all of this out, we get that the velocity when the ball hits the ground is going to be 143.5 feet per second. And so, yeah, I mean, this makes sense if you think about it in this way. So the ball starts from rest, and then after 1 second, its speed increases to, well, what's g? 32.174. And then after 2 seconds, it increases to 2 times this, and so on. And so after 4.5 seconds, about 4.5 seconds, the speed will be 143.5. So the question is, a ball is thrown in the air from the top of a building with a height of 80 feet. It is thrown with an initial velocity of 80 with 64 feet per second. When does the ball reach its maximum height, and what is the ball's velocity after 2 seconds? So again, I like to start off with this equation. S is equal to ut plus 1 over 2 at squared. And then I'm just gonna choose that, well, you don't really much have to worry about this, but like it's good to think about it. I'm gonna say going up, the acceleration will be negative. So I'm just gonna pick g as negative, but I mean, you don't necessarily have to, but I'll pick g to be negative. So, well, if we have that the distance is given by this, then ds by dt, or the change of speed with change in time, is going to be the velocity. And that's just going to be the derivative of this with respect to t. So the derivative of ut with respect to t is just u. and the derivative of half at squared with respect to t is going to be at. Okay, now I'm just picking a to be negative. I mean g, my bad. I'm picking g to be negative. I'll call this g. And so we have that our velocity is given by u plus gt. Okay, so this is our velocity. Okay, so now I want us to think about a few things. So if you throw a ball up, it's gonna go until at the maximum point, at the highest point that it goes, the ball is just gonna stop entirely. So we're looking for the point where velocity is equal to zero at the maximum point. Okay. And so we can just sub in values now. So we have sub in values here. We have 0 is equal to u. U is 64. And then we chose our g to be negative. Negative, what's the value for g? 32.174 times t. So we're solving for t again, because the question is, when does the ball reach its maximum height? So if we just move this to that side, negative 64, and if we divide by, oh, negative 64 is going to be 32.174t. If we divide by negative 32, we get 64 divided by 32.174 is equal to t. Okay, which then tells us that t is equal to 1.99 seconds. So the ball is at its maximum height after 1.99 seconds. Okay. So now that we have that down, we can answer the second question. What is the ball's velocity after 2 seconds? Well, the function for velocity is v is equal to u plus gt. Okay. So v is equal to u is 64. And our g, we chose it to be negative 32.174 times t. And t here is 2 seconds, because we're trying to find out what's the velocity of the ball after 2 seconds. Well, times 2. And then if you work this out, well, you'll get 64 minus 64.3. And this is obviously feet per second. Okay, feet per second. Well, this comes out to negative 0.4 feet per second. Okay. Well, negative 0.3, my bad, negative 0.3 feet per second. And if you think about it, so if at 1.99 second, the ball has stopped, it's reached its maximum height. So it's like this. So it starts off at a height of 80 feet, and then it goes up. And after 1.99 second, it is at its highest point. So t is equal to 1.99. This is the highest point. And then it'll just start falling back again. After 2 seconds, it's going to be here, just starting to accelerate and speed up again. So you expect it to have such a small speed after like a tiny fraction of a second. It's going to be moving really slow, but it's going to be moving in the opposite direction. Notice that the speed after 2 seconds, after it reaches the highest point, the speed is going to be negative. Okay. So a car moves with a velocity v equals to t squared minus 13t minus 7, where t is in seconds. Find the acceleration of the car each time the velocity is 0. So first we need to find when is the velocity 0. So when v equals 0, we have v of t equals 2t squared minus 13t minus 7 equals 0. So forget about all of this. You're trying to solve this equation, which is a quadratic equation in t. And the way that we go about solving that is by factoring. First, we multiply 2 and 7 to get a negative 14, right? Then we're looking for two factors of negative 14 that add up to negative 13t. So then we have 2t squared, okay, plus 1t minus 14t minus 7 equals 0. Okay, because if you multiply 1 and 14, you get negative 14, but if you add them, you get negative 13, okay? Then we could factor out a t from the first term, okay? And then we get 2t plus 1 in here. And then if we factor out a 7 from the second term, negative 7 from the second term, we get 2t plus 1 equals 0. And then we could factor out a 2t plus 1, okay? And what we get is t minus 7 equals 0. So 2t plus, so this means that 2t plus 1 equals 0, or t minus 7 equals 0. So if we solve this one, we get that t is equal to negative half, or that t equals to 7. Okay, so we get that t equals to 7. So again, if you have time, you could mess around with this, but the concept of negative time doesn't make much sense. So I won't do the work for this, and I don't think you have to, because like negative time doesn't make sense. But now we have that the velocity is 0 when t is equal to 7. Okay. So we want to find the acceleration of the car. So to find acceleration, by definition, acceleration is equal to the derivative of velocity with respect to time. So we're taking the derivative of this with respect to t. So the derivative of 2t squared is going to be 4t, and the derivative of negative 13t is going to be negative 13. The derivative of negative 7 is going to be 0. So our acceleration is equal to 4t minus 13. Okay, so 4t minus 13 is our acceleration. And then we want to find the acceleration when t is 7. So we have that a is equal to 4 times 7 minus 13, which is equal to 28, minus 13, which is then equal to 15. So the acceleration is 15 when t is 7. You could do it for negative half, but it doesn't make sense to have negative time, at least in this context of a moving car. Okay, so we move on to number 12. And number 12 says a car's position is modeled by the function s of t equals t cubed minus 6t squared. Determine the times at which the car is moving forward. Okay, so if we have the position function to determine at which time the car is moving forward, we just basically have to find the velocity function. So we want to find v, and then determine at what time v is positive. Okay, so velocity is equal to the derivative of position with respect to time. So we want to take the derivative of t cubed minus 6t squared. So the derivative of t cubed is 3t squared minus the derivative of 6t squared is negative 6 times 2t. So this is 3t squared minus 12t. Okay, so 3t squared minus 12t is our velocity function. So we just need to find when this is negative, okay? And so first I want to find when this is zero. When is the velocity zero? So v is equal to zero when 3t squared minus 12t is equal to zero, which means that 3t into t minus 4 is equal to 0, which means that t is equal to 0 or t is equal to 4. Okay, so if t is equal to 4, so if t is equal to 4, that means that we're not interested in times that are less than 0, but yeah, I mean, yeah, we could test it out. So let's test this function at so when t is less than 0, such as t equals -1, our velocity then, which honestly doesn't make sense, is 3 into -1 squared minus 12 times t times 1, -1, which is equal to 3 plus 12, which is equal to 15. So I guess when this is positive, and then we just have to look between 0 and 4. So when t is less than 4 or equal to 4, less than or equal to 0. Example, if we pick t equals 1, we get that the velocity is 3 times 1 squared minus 12 times 1, which is equal to 3 minus 12, which is equal to -9. So the velocity is negative between 1 and 4 seconds, which means the car is going back, is backing up. So let's check what when t is greater than 4. For example, when t equals 5, our velocity is 3 times 5 squared minus 12 times 5, which is equal to 3 times 25 minus 60, which is just 75 minus 60, or 15. So our velocity is 15, which is positive. So the only answer that makes sense is to say the car is moving forward when t is greater than 4 seconds. Because if we don't start looking at the car, like we start looking at the car when t is equal to 0 on the first second, and we don't know what's happening to it there, but we can tell that between 0 seconds and 4 seconds, the car is backing up, and then velocity being positive after 4 seconds tells us that the car is now moving forward. I hope that helps. Well, find the derivative of the following. So these are slightly more complicated functions, okay? But if you think of this as cosine of x, all of this squared, you can use what's called the chain rule. And so basically the chain rule is, well, the easiest way that I can think about it is you take the derivative of the inside function. So if you think of this as two functions, you have cosine of x as one function. So you take the derivative of the inside function and you multiply it by the derivative of the outside function, okay? So our inside function here is cosine of x, and our outside function is just like the square function. So if you think, yeah, it's just a square function. So we're taking one function and squaring it. So it's a composite function. So the derivative y prime, you're gonna have to use this technique. So what's the derivative of the inside? Well, the inside is just cosine of x, excuse me, and the derivative of cosine of x is just negative sine of x. Okay. And then let's think about the derivative of the outside. So when you have a power of 2, you multiply by 2, and then you just have cosine of x raised to the power 1. So this is just negative 2 sine of x cosine of x. Okay. So, and you can simplify this further if you want, but we're not interested in that right now. So this is the correct answer. Number 14, f of x is equal to 5e to the x into x squared minus 6. Well, here we'll use the product rule. So product rule. Remember, we said that the product rule, if you are taking the derivative of f times g, you just first, so you take f and multiply f by the derivative of g, and then you take g and multiply g by the derivative of x. So in our case, if we say that this is f and that is g, okay, so we'll just take f, and f is just 5e to the x. So if we say this whole thing is f, and then we want to multiply that by the derivative of g, so the derivative of whatever's inside here. And so the derivative of x squared is 2x. The derivative of negative 6 is just 0, okay? Plus, we want to take g, so we do x squared minus 6, and we want to take that and multiply it by the derivative of f. So the derivative of x is just 5e to the power x. So again, you could leave it like this, and it's correct. Or if you want to be fancy, you could factor out 5e to the x, and then you get 2x plus x squared minus 6, which you can also write as 5e to the x multiplied by x squared plus 2x minus 6. So it's up to you. You don't have to do this last step. You can just stop here and the answer is correct. But if you want to simplify, you could do this too. Ooh, so number 15 is going to be a lot of fun. So again, we're going to have to use a combination of the product rule here because we're multiplying this function by that function. And so notice that this is a composite function. So we're going to use the product rule, but we're also going to use the chain rule. Okay. So the product rule again says, so if this is our f and that is our g, so if you're taking the derivative of f times g, you just want to say f multiplied by g prime plus g multiplied by f prime. Okay. So f multiplied by g prime, well, this is going to be e to the 3x multiplied by g prime. Well, g prime is first you want to just take the derivative of the inside function. So derivative of cos is just negative sine of x squared plus 3x. Okay. And then you want to take that and multiply that by the derivative of the inside function, which is 2x plus 3. Okay, so that's how we do the first part. And then we want to add this to, we want to take g. So g is just cosine of x squared plus 3x. And we just want to multiply this by the derivative of f. So derivative of f is 3e to the 3x. Okay. Yeah. And then, yeah, this is the This is the derivative. I mean, it's a bit tricky, but if you just think about it, you're multiplying two functions. One is very easy. F is very simple function. G is a very complicated or like a composite function. And so we just we take f, e to the 3x, and multiply that by the derivative of g. And remember to find the derivative of g. Oh, my bad. I really, wait, I think I messed. No, did I mess up here? Let me see. So, yeah, so it's the derivative of this. It's so derivative of cos is just negative sine of x. Yeah. So negative sine of whatever's inside times the derivative of what's in here. So which is this. No, this is correct. Yeah, this is correct. So this is how you do it. Just yeah, follow the steps that I took and you'll be fine. Okay, so number 16. So number 16, if I want to find h prime of x, okay, I want to find h prime of x, I'm gonna have to use the quotient rule. And you remember the quotient rule is if I'm finding the derivative of f over g, okay, this is gonna be g squared, and then I put a g here and multiply by f prime multiplied by g prime times f. Okay, so it's gonna be like this. So now case g of x is equal to, so g is equal to 3x minus 2 squared, and now f is equal to sine of x. Okay, so the derivative of g that we'll need this. It's just gonna be, again, this is a composite function. So you take the derivative of the inside, which is just 3, is 3x plus 2. The derivative of 3x plus minus 2 is 3, and then you multiply by the derivative of the outside, so you bring down a 2 here, and then what you have left inside is 3x minus 2, so this is just 6 into 3x minus 2, and the derivative of f of x, which is sine of x, so this derivative, so f prime will be cosine of x. Okay, so now we have all the values we'll need. So h prime of x is equal to, well, we take g of x, so we'll take 3x minus 2 squared, and we need to square this, okay? And then we come up here and say we need g. Where is g? So we need g. G is 3x minus 2 squared. And then we take that and multiply by f prime, which is cosine of x. Okay. And from that, we subtract g prime. So g prime is 6 times 3x minus 2. So we take g prime and multiply it by f. And now f, we said, is sine of x. Okay. Yeah. So this is just going to be 3x minus 2 squared cosine of x minus 6 into 3x minus 2 sine of x. Okay. And all of this we divide by 3x minus 2 raised to the power 4. Okay. We could do some further simplification, but we don't have to, so I'll just leave it in this form. Okay. And then lastly, we have number 17. Y is equal to tan cubed of e to the power 2x. And again, this is a composite function where you have our outside function as tan cubed. So this is tan of e to the 2x. And then all of this is cubed. Okay. So to find the derivative or y prime, we just take so the derivative of the inside, excuse me, the derivative of the inside is gonna be well, so we have to do the derivative of the outside first. So the derivative of the outside is just 3 times tan of e to the 2x. Okay. And so all of this is squared. Okay. So we're squaring the tangent function. And then we want to multiply that by the derivative. I'll write this as that. So the derivative of tan e to the 2x. Okay. And then tan e to the 2x, this is a composite function. So again, we need to take the derivative of the inside. So the derivative of e to the 2x is 2e to the 2x. So we take the derivative of the inside and multiply that by the derivative of the outside. Okay. So this is going to be, and remember the derivative of tan x. So if we find d by dx of tan x, that's just secant squared of x. So this is just a fact that you should know. Okay. So if we come back to our problem, we're trying to find d by dx of tan e to the 2x. So this is going to be 3 tan squared e to the 2x times the derivative of the inside, which is 2e to the 2x times the derivative of this tan function, which is just secant squared of e to the 2x. Okay. And then we could just rearrange some terms here. And we have 3 times 2 is going to be 6. So this is 6 e to the 2x tan squared e to the 2x. And this multiplied by secant squared e to the 2x. Okay, perfect. So I really hope that this helps, and you can go back and watch it to learn technique if you're stuck.